Example, find the area enclosed by y sub 1 equals x cubed minus 6x and y sub 2 equals 8 minus 3x squared. Before we get to the calculus, we're going to review how to solve a third-degree polynomial function. Consider the function f of x equals x cubed plus 3x squared minus 6x minus 8. We're going to apply the rational zeros theorem to get all possible rational zeros. They are plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. Let's just pick one of these and check using synthetic division. I'll try with x equals negative 1. To do synthetic division, I set it up so that the negative 1 is to the left of the synthetic division bar, and then we list the coefficients only of the polynomial. For x cubed, the coefficient is 1. For 3x squared, the coefficient is 3. For negative 6x, the coefficient is negative 6. And for negative 8, we write negative 8. To do synthetic division, we start with the leading coefficient and add straight down. 1 plus nothing is 1. Now we take that 1 and multiply it to the negative 1. Together that's negative 1. Put it below the next coefficient of 3. So you have 3 followed by negative 1. Add those two numbers together. The result is 2. Use the 2 and multiply it again to the negative 1, which gives you a product of negative 2. Put it under the negative 6. Add together negative 6 and negative 2. The sum is negative 8. And multiply negative 8 to negative 1. The product is 8. Put it below the negative 8. The sum of negative 8 and positive 8 is 0. The final column result being 0 tells us that x equals negative 1 is indeed a divisor. So we can take our polynomial function, f of x equals x cubed plus 3x squared minus 6x minus 8, and write it as a product of the x plus 1. And what remains, using the coefficients at the last row of synthetic division, 1 times 1 degree lower than what we started out with, x squared, plus 2 times 1 degree less is x, minus 8. Now factor the quadratic x squared plus 2x minus 8, and we'll have this cubic factored to x plus 1 times x plus 4 times x minus 2. We see that f of x equals 0 when x equals negative 1, x equals negative 4, and x equals 2. Let's go back to the original problem. Find the area enclosed by y sub 1 equals x cubed minus 6x and y sub 2 equals 8 minus 3x squared. This problem does not give x values, so we need to determine the points of intersection. To find the area of the region, we need to sketch the graphs of the two functions on one xy plane. Y sub 1 is a degree 3 polynomial that rises through the third quadrant into the second quadrant, turns downward, goes through the origin, and turns to rise again in the fourth quadrant. Y sub 2 is a downward-facing parabola with y-intercept at 8. The graphs show 3 points of intersection and 2 different regions of enclosed area. We previously found the 3 points of intersection for x cubed minus 6x equals x minus 3x squared. The x values we got were x equals negative 4, negative 1, and 2. They match our drawing. From x equals -4 to x equals -1, let's observe that the cubic is above the parabola. So the integral would be -1 to 4 of the cubic function x cubed minus 6x minus the parabola 8 minus 3x squared dx. The functions switch. From x equals -1 to x equals 2, the parabola is above the cubic, so the integral would be, for -1 to 2's integral, it's the parabola 8 minus 3x squared minus the cubic x cubed minus 6x dx. Note we have two separate integration problems here. Let's do the leftmost region first. We'll distribute the minus sign, and that'll become the integral from -4 to -1 of x cubed minus 6x minus 8, and minus 3x squared would be plus 3x squared dx. We'll find the antiderivatives or integral of each of the terms. The integral of x cubed is 1/4 x to the 4th. The integral of 6x is 3x squared. The integral of 8 is 8x. And the integral of 3x squared would be 3 divided by 3 times x to the power of 3, or x cubed. We evaluate that from -4 to -1. So we take the integral and put in the -1 every place there is an x. That results in 1/4 -1 to the 4th minus 3 times -1 squared minus 8 times -1 plus the quantity for -1 cubed. And then we evaluate the same integral but at -4 and subtract it. So we'll have minus 1/4 -4 to the 4th minus 3 times -4 squared minus 8 times -4 plus the quantity for -4 cubed. Let's get our arithmetic done. For the first bracket, it simplifies to 17/4. And for the second bracket, we're going to have minus -16. Add those two numbers together, and the area for the first segment, the leftmost one, is 81/4. Now let's determine the integral for the second region. We'll distribute the negative, and that integral will become the integral from -1 to 2 of 8 minus 3x squared minus x cubed, and then negative and negative would give us plus 6x dx. We'll find the antiderivative or integral of each of the terms. The integral of 8 is 8x, minus the integral of 3x squared is x cubed, minus the integral of x cubed is 1/4 x to the 4th, plus the integral of 6x is 3x squared, and we evaluate that integral from -1 to 2. That means we're going to put the 2 in every place there's an x. That'll be 8 times 2 minus 2 cubed minus 1/4 2 to the 4th plus 3 times 2 squared. We'll subtract, evaluate it at -1. So you're going to have minus 8 times -1 minus -1 cubed minus 1/4 -1 to the 4th plus 3 times -1 squared. Let's do the computation in the first bracket. Comes out to 16. Computation for the second bracket, we're going to have the minus, and of course minus 17/4 The sum of these is 81/4. The total area is the sum of the two areas, 81/4 plus 81/4, or 81/2.